In the power washer problem, I use it as a think, pair, share activity where students thought on their own for 3 minutes and then worked with a partner for 7 minutes. And then we shared out solutions and I presented a different type of method for about 10 minutes. On the problem, they did prefer the table method, and we talked about, well, what if it would have intersected at a greater number? If the equations had bigger numbers in them, the table method might not be as effective, and you might have to result using another method. We also talked about graphing that they're also already used to, which is the x-axis would have been the scaled by 1s, and the y-axis would have been scaled by 5s or 10s. And then I said, well, another method you could use is that if you had y equals 2x plus 25, and the other equation, I'm just using the same problem with a different method, y equals 5x plus 10. Well, we know that x was defined in this case as the amount of hours, or number of hours, and y was defined as the cost of the power washer. And we can see from the table easily with these numbers that at 5 hours the power washer costs the same at which was $35 at 5 hours. And they did get the solution correct, and I told them that they're welcome to use the table method if that's the method they prefer, as long as they can find the solution and show reasoning. And then I said, well, when we're solving for x and y, what are we actually solving for? Well, we want x to be the same value and y to be the same value, so that's the one point on the graph where they intersect. And so if y is equal to 2x plus 25, if I know y is the same value that I'm looking for, then I know that if y is equal to 2x plus 25, this y is also equal to 2x plus 25. And so I can substitute 2x plus 25 in for the y and set it equal to the other expression that in terms of x, that is 5x plus 10. And now I have it down to one unknown, and I actually can solve the equation. So if I subtract 2x, I get 25 equals 3x plus 10. And then if I take the 10 to the other side, subtract 10, I get 3x is equal to 15. And then we can see that x is 5, so at 5 hours, and if we plug it back into one of the equations, you would see that 5 times 5 is 25 plus 10 is 35 if I plugged it into the second equation. And you can see that that's going to come out with the same answer, the same intersection point. We also talked about why did we not use 0 in the chart, and that's because at 0 hours, even though it shows that it would cost them $25 on plan A if they plugged in 0 for x, that's not reasonable because you're not going to be charged for a power washer at 0 hours. So we talked about how the domain again is restricted in this problem like we previously discussed in other problems.